Most of our water in western Hays County comes from groundwater. The water is not in big lakes or pools in the subsurface, but it's in the holes of the rocks. It's in the rocks. In this groundwater district area here in central Texas, the aquifer is the Trinity aquifer. The Trinity is Cretaceous, it's lower Cretaceous. It is subdivided into 3 geologic units, and there is production out of each one of these units. The only recharge that is available is through precipitation, through rainfall. If it rains, the aquifer is very forgiving. It absorbs that water. The water percolates down from the surface into the subsurface, filling the aquifer. Since we use the aquifer, we need to look at and understand how that aquifer is recharged. What happens to that water? Our district's responsibility is to manage the aquifer, manage it in a sustainable manner, and to balance that use of the water for residential or industrial or agricultural purposes, and the need for the water to be in our springs and in our creeks. When I moved here to Dripping Springs, the town was dry, and my well was wet. And now I'm in a situation where the town is wet and my well is dry. Hays County is one of the fastest growing counties in Texas, indeed, perhaps even in the United States. Large companies are coming in and placing their offices in this area. And that's good. That's good. It's good for development. It's good for prosperity. The only thing we have to do is figure out a way to manage it. That's the critical thing, is to have that balance, to have that management balance, to be able to provide services at the same time to maintain the basic reason why people have moved here to the hill country in the first place. It's not only the people who live here that use the water, but the streams use the water, the springs use the water. The whole atmosphere, the whole environment of the hill country is sustained by the aquifer. We believe that the Monitor Well project will have multiple uses. As we drill the well, samples of rock come up from the subsurface, and we're able to cut a solid rock core. So we're able to actually hold something in our hand to see what that subsurface looks like. That core then can be looked at under the microscope, so we can tell something not only about the rock, but about the holes in the rock. With the core data that we have, we can come up with an actual three-dimensional picture of what we're looking at in the subsurface, and therefore have a better ability to manage to understand the aquifer.
We've just taken the first 3 cores, and in the core we found some shell material. Some of the shell material has been dissolved away, and there are holes. What we're trying to find out is how those holes are connected. This is part research, part exploration, as we attempt to understand how these aquifers were formed, and how they produce and how they continue to produce, and how much longer they're going to produce.
In order to have a clearer idea of what the groundwater levels are, you have to have some sort of historical data. Periodically during the year, we can sample the well, and we can sample the well for water quality. Who's it good for? Well, it's good for all of us. It's good for the municipalities, it's good for the local landowners, because this is going to give them a real-time picture of what's happening in the subsurface. They can go online, they can see this data right away, and it allows the decision makers to make better and informed decisions. There is tremendous potential out there. We've got to take advantage of the schools that are here. We have to take advantage of the opportunities that we have for education. We think that's the best way to do it, by working together with our neighbors, with our friends, with our community.